Hello everybody, welcome to the community track and welcome to Com401 Scaling Containers on AWS. I'm Vlad, I'm an AWS container hero, and today we're going to be talking about how you can scale your containers, how you can reach more users, and how you can do all that while saving money and moving even faster. You may or may not be aware that in April 2020, I published a blog post comparing the performance of different container orchestrators in AWS. My main focus then was comparing Fargate workers with EC2 workers. Just like with fashion though, the spring 2020 results are terribly outdated. So the first item on our agenda is to be looking at the updated results, winter 2020 edition. After that, we're going to be checking some ideal applications for each service, and we're going to end up by discussing how you can optimize your costs so you can have even better margins. Before we get into that though, we need to do some prep work. First of all, this is a 400 level talk. This is an expert level talk, and it is for people who are deeply familiar with the topic and who have implemented the scaling solution on their own already. That means I will not be discussing how to implement cluster autoscaler or AWS autoscaling policies. That is beyond the scope of this talk. What we are going to be discussing are the effects of those implementations and how you can tune them a bit for even better performance. That said, if you haven't already implemented the solution, you can still get a lot of value from this talk by seeing what is the best fit for you and then going further and deep diving on what you actually need to learn how to implement. So, how are we going to be actually testing how fast containers can scale? Of course, we're going to be using an application. It's going to be a Hello World style application made out of just one container. Both pods in Kubernetes and tasks in ECS can have more than one container, but we are using just one container for simplicity. It is a rather small container at 1 CPU and 2 gigabytes of memory, and we are using spot instances whenever possible. We are trying to have good margins as we can. I also got some limits increased for some AWS services. Whenever that is the case, I will be mentioning that, and I made sure to get limits increased to levels that are realistic. I'm not presenting results with super custom limits that only some customers can get. This is not a concern. Every single one of you will be able to get these limits and achieve this level of performance, or even better, by easily opening up support tickets with AWS for limit increases. Finally, we are performing all the tests in North Virginia in US East 1. In the test we did in April 2020, we have discovered that performance levels are very similar between regions, so there wasn't any value in running the test in more than one region. That said, we are going to be scaling from one container up to 3,500 containers. That is very much an extreme test case, and it is very much a forced scaling pattern. Most of you will not be scaling your containers that aggressively. We're doing this because we want to see how fast different orchestrators can scale in an extreme test scenario. For your applications in the real world, you may be seeing some differences. Those are unavoidable and can come from anywhere. For example, if you have a bigger container, the container size and pulling that image can very much have an impact. If you have a container that takes a couple minutes to start up and to be able to serve requests for your customers, that will also have an impact. So beware, your mileage may vary in the real world. That said, let's get right into the results. So, these are the previous results from spring 2020. Anybody want to make some guesses on how these lines have moved? I'll wait. There is a dramatic shift in performance, especially for Fargate. If we overlay the results on top of each other, you can see how dramatic the performance increase is and how much things have improved in such a short time. There is also surprise. The green line that shocked both me and AWS, and that has shockingly good performance. I'm not yet telling you what that line is. It's going to be a surprise, but try and see if you can guess what the green line is before I actually reveal it. Let's deep dive into the results, and let's start with EC2 workers. First up, EKS on EC2. We can barely see the two different lines here, so there isn't really any performance improvement in EKS on EC2 performance. Before we discuss why that is, let's discuss how we actually tested this. So, first of all, I did submit a support ticket with AWS to get my EKS control plane pre-scaled. I know from my work that the EKS control plane scales very fast and is very responsible, but I wanted to eliminate that variable. I'm not testing EKS, I'm not testing how well the EKS control plane scales. I'm testing how fast containers scale. There was an extra variable that I wanted to have removed. You can also do this by submitting a support ticket with AWS, getting your workload evaluated, and then your control plane will be pre-scaled to better handle spikes. That won't even be needed soon because the EKS console will have native support for this as it was announced at the AWS Container Day. Second of all, as I said, cost optimizations are an overarching theme of this talk, so I did use EC2 spot instances. I did follow best practices. I used multiple families and different instance types, all for better spot availability. I did that in a single ASG using launch templates. That ASG is scaled by cluster autoscaler from one EC2 instance to about 250 instances. So there is no prep work done for EKS. EKS will have to scale, and cluster autoscaler will be the one that will be adding the EC2 instances. For the actual application, I'm using a single deployment, and I'm scaling that deployment manually to 3,500 replicas. So no horizontal pod autoscaler or anything like that. Again, very aggressive and forced testing scenario. So do you think the green line could be EKS on EC2? Could that be a super optimized version of cluster autoscaler? It could be, but it's not. Again, I wanted to target workloads that everybody can easily achieve. Fine-tuning cluster autoscaler or using custom autoscaler is a rather complex engineering effort, and I did not want to get into all that. The green line is unfortunately not an optimized version of EKS on EC2. Up next, ECS on EC2. I don't have any previous results from April. I did not test this in April, so we're just going to be looking at the most recent results from this winter. We can see here that I'm testing two different networking modes on ECS on EC2, the bridge and AWS VPC networking modes. We are also scaling to 1400 containers. I'm basically zooming in here on the graph, so it is a lower scale. The reason I did that is because I wanted to talk about why there is such a difference between the two networking modes. The dashed line is slower because it uses the AWS VPC networking model. And that has to create ENIs, it has to attach those ENIs to the EC2 instances, it has to set up networking for the pod. That takes a while. So there is a tiny delay and there is a tiny difference in performance, but it is not that dramatic. As I said, cost optimization is an overarching thing in our presentation, so I did use EC2 spot instances. It's pretty much the same setup I use for EKS on EC2, but not fully. There are two major ways to implement scaling the underlying EC2 instances in ECS. The first option is a bit more classic, is the AWS autoscaling policy. That is a scaling policy attached to a CloudWatch alarm. The second option is ECS cluster scaling that dynamically looks at the number of containers that don't have any place to run and automatically changes the ASG size for you, both up and down. I didn't exactly want to get into optimizing either one of those variables. It is very, very, very application dependent. It depends on your use case, it depends on how you're scaling, it depends on what metrics you're using, and I wanted to eliminate that variable. For that, I just pre-scaled the ASGs, and I used an autoscaling group with a fixed size of about 250 nodes, enough for the containers to have a place to run. That is a bit unfair to EKS. EKS, in contrast, had to scale up, it had to add the instances, and it had to wait for those. But we also wanted to look here at the dedicated results for ECS, and I think this is the best way to do that. I did get a limit increase for ECS. I talked with AWS support, I validated my workflow, and I got my limit set to 2 transactions per second per service. That means that theoretically, ECS could launch up to 2 containers every single second. As I said, pulling the image, actually starting the container, and all the processes involved do add a delay to that, so we are not actually hitting that precise limit. This is kind of an equivalent increase to what we did for the EKS control plane. By getting this limit raised, AWS basically pre-scaled parts of ECS for us. So, do you think the green line could be an optimized version of ECS on EC2? Unfortunately, it is not. We'll see what the green line is. It's still a mystery. Now that we are done with both orchestrators on EC2, let's discuss how they compare and what the impact of using EC2 for the compute plane is. We can see that EKS is a bit faster reaching the target, but ECS does indeed start running those containers faster, partly due to the pre-scaled auto-scaling group. ECS already had those instances prepared, it just had to start running containers. In contrast, EKS had to decide what instances to use, what auto-scaling group to be scaled up, and had to wait for those instances to become ready and then join in the cluster. If you look there though, there is a delay. There is a scaling delay. For EKS, that is about 2 minutes. For ECS, that is about 1 minute. What do you think the impact of this delay is? How this impact what applications you would be running on EC2 compute planes? Would you be running web applications using an EC2 compute plane? I wouldn't. When I go to a website, I don't want to wait 2 minutes for my web page to be sent back. Would you be running anything that is user-facing? Think stuff like API endpoints. I wouldn't. I like my application to be fast, and again, I don't want to wait 2 minutes for my application to respond. Would you be running anything that is latency sensitive in terms of response? I wouldn't. That 2-minute delay might not sound like much, but for applications that have to answer in less than 1 second, that can be worlds of time. Claire at last year's reInvent in the keynote with Dr. Werner Vogel had a way better presentation on this, discussing exactly what the difference is, how this actually impacts the user, and what the possible remediations for it are. I highly suggest you go and watch that awesome talk. That said, what is the fit for EC2 compute planes? Would you run background work on EC2 compute planes? I definitely would. For anything that is not time sensitive and that requires scale, this is absolutely perfect. Would you run any network bound services? I definitely would. You can get AWS instances that have dedicated 100 gigabit network connections, and those are an absolutely perfect fit for any application that is network hungry. Would you be running anything that requires GPUs, like say machine learning or media workloads? Definitely. There are multiple instance types that offer GPUs and that can easily join both ECS and EKS clusters. Would you be running specific software that requires ARM CPUs? I definitely would. Graviton 2 comes with both amazing performance and amazing cost, and I would definitely want to take advantage of that. That said, are there any workarounds for that delay? Are there any improvements you can do to get rid of that delay? Yes, there are. You could configure very aggressive scaling. As soon as one request comes in, you could predict that you would have increased traffic and you would figure very aggressive scaling on that. Depending on how predictable your traffic is, this may or may not be an option. You could pre-warm and prepare capacity for your cluster, but I don't really like that option either because it adds extra cost. The whole advantage of the cloud is that you can scale up and down and save costs, and having capacity prepared and ready to serve traffic is just throwing money out the window. If we zoom out and look at the results again, we can see that Fargate does not actually have that delay. Fargate is on-demand compute, and AWS is the one that has to stress about pre-warming capacity and how aggressive scaling should be. So Fargate could very much be a solution to our problem. That said, we're now moving and we're now discussing Fargate workers. Let's start with EKS on Fargate. The scaling performance for EKS on Fargate has seen a dramatic improvement. We can see here that we went from about 1 hour to less than 20 minutes to scale to 3,500 containers. That is an impressive improvement that came with absolutely no user effort on my side. AWS improved Fargate and we all just get to take advantage of that. Awesome. So how did we test this? Again, I did pre-scale the EKS control plane. I wanted to eliminate that variable and I'm not testing EKS. I did get my limits changed for this. After validating my workflow with AWS support and discussing with the service team, I did get my limit set to 10 transactions per second per AWS account. This is not a per service limit, it's a per AWS account limit. You can check your limits level with AWS, and if you need that increased higher for even higher performance, you can support the kit. Could the green line be a tuned EKS on Fargate? Could that be a custom limit? No, I said I wasn't going to get into custom extreme limits. I wanted to keep this general in reach of everybody. So, could it be using more than one Fargate provider? Could it be using more than one deployment? Unfortunately, it is not. If you can actually see here, we have three lines in there comparing one Fargate provider and one deployment with three deployments and one Fargate provider and one deployment and three Fargate providers. All the combinations, all of them have pretty much the same level of performance. So the green line is unfortunately not the tuned version of EKS on Fargate. That said, let's move on to ECS on Fargate. ECS on Fargate also saw dramatic speed improvement. It went from about 1 hour to 40 minutes. It's not as dramatic as EKS, but let's talk why. I did get my limit changed for this one too. We have that 10 transactions per second per AWS account limit already increased from when we ran the EKS on Fargate test, and we had the 2 transactions per second per service limit for ECS already increased. These are the only 2 limits that I got increased again after validating my workflow with AWS. Could the ECS on Fargate be the green line that has amazing performance? It is indeed. The secret here was the limit for 2 transactions per second limit. That was a per service limit in ECS. So if I actually increase that number, I get more containers launched every single second. I still have to respect the 10 transactions per second limit that is per AWS account, but using more services, I can get closer to that limit. We see here that using 10 services was the optimal result for me. It did take a bit of tweaking and I did have to try a couple of different service numbers, but 10 services was the one that was most successful for me. I did say at the beginning of the talk that I'm not considering any complex improvements or tweaking of services. I'm showing this because I don't think that splitting an application into multiple services on ECS requires as high of an effort involved compared to the other methods that we discussed. This is something that can be done relatively straightforward and as we can see here, the performance improvements are very much dramatic. That said, let's move and discuss the advantages and disadvantages of Fargate as a compute plane. We do see that EKS on Fargate is by default faster than ECS on Fargate, but if we add the slightly optimized version of Fargate on ECS, we get better performance. What results you want to take from here, it's totally up to you. We're going to be discussing all of them either way. So, where would you use Fargate? Would you use Fargate for web applications? I definitely would. There is no scaling delay and any latency should be way lower than compared to using an EC2 compute plane. Would you use Fargate for user-facing applications like APIs? I definitely would. Fargate can scale very fast with no delay, so again, the user impact should be minimal. Would you be using Fargate for anything that is response time sensitive, for things that need to scale fast? I definitely would. There is no delay in scaling, but we still get to scale to a lot of containers. Would you use Fargate for background work? I definitely would. As you can see here, Fargate can easily scale to a large number of containers. I know I said I would also be using EKS on EC2 or ECS on EC2 for background work, and that is fine. We can use multiple services for the same workload. There is nothing stopping us. That said, would you use Fargate for network-bound services? I wouldn't. Fargate does get great networking performance, but we don't get those awesome 100 gigabit network pipes that we can get with EC2 instances. Would you use Fargate for GPU tasks? I wouldn't. There is not yet any GPU support for Fargate. I imagine it's coming sometime in the future, but right now it is not supported. It's the same thing for ARM workloads. I wouldn't be running ARM workloads right now because that is not an option. Would you be running Windows-only apps? Windows is also currently missing from Fargate. We'll see what the future holds. With all the talking of scaling and what workload we would run where, we have to talk about costs. So let's compare the cost for ECS versus EKS. First of all, the cluster. ECS does get free clusters, so you can create as many clusters as you want at no charge. In contrast to that, EKS does charge 10 cents per hour per cluster. It's not a large sum, but for teams that have 10,000 applications, each of them with their own cluster, it could get pretty pricey. Let's move on to workers. Both ECS and EKS support EC2 instances. Both of them support all types of EC2 instances with all the purchasing option, from on-demand to the slightly newer savings plan. Both EKS and ECS support Fargate, but there is a difference here. EKS on Fargate does not yet have any support for Spot. That is a big difference. Fargate Spot on ECS definitely has a cost advantage here. Fortunately, both of them do support compute saving plan. Most people would just stop there. Cost analysis done, and they totally ignore the people cost. That is a huge mistake that I often see done in the industry. The AWS cost is very easy to see. We all get that monthly bill, and it is very easy to start optimizing and working on lowering that cost. Ignoring people cost is a big mistake though. A certain service might be, say, $100 cheaper, but if you're spending a lot of development time on that, you would, in the end, be spending more money overall, and you will not be seeing that just looking at your AWS bill. The second thing that people are often ignoring is the opportunity cost. If you have 20 of your engineers working on maintaining infrastructure, you're missing opportunities. Those 20 engineers could be working on something better. They could be working on new features for your applications. They could be working on reaching even more users, or they could be working on getting even better margins. Having them maintain infrastructure is a missed opportunity cost. Let's compare the people cost of the two different options. First of all, EKS does get upgrades every 3 months. They are minor level upgrades, but you do need to see what features were released, how they are impacting your applications, and you do have to upgrade your clusters. There are also component upgrades like networking, DNS servers, and so on. I estimate this to be between 1 and 20 engineers. If you're just running a default setup, this should not require that much maintenance. On the other hand, if you're running custom service meshes and many EKS integration tools, you do need a platform team, and those can grow a lot. Moving on to the EC2 instances, these EC2 instances have to get MI updates, including security updates, and you have to do component updates. Component updates could include things like CloudWatch offering scaling on even more metrics. You might want to take advantage of that for that ECS cluster scaling. For EKS examples, we could think of cluster autoscaler upgrades, AWS load balancer controller upgrades, and so on and so forth. They aren't this big, and usually most of them do offer migration paths, so I would estimate this to be about 1 engineer. There are also version upgrades for Fargate that you need to consider, but historically these have been rarer and not that user impacting, so I would not estimate any work hours to that. It would just be normal application maintenance. We see that there are quite different people costs involved between ECS and EKS. Depending on your applications, depending on how intensely you're using your orchestrator, depending on how your applications behave, you might end up spending a lot in people costs. That said, what are some ideal fits both in terms of cost and performance? First of all, nobody has to scale to thousands and millions of containers, so let's start at hundreds of containers. As we can see here, Fargate has very much a specific advantage because it does not have that delay. You still get absolutely amazing scaling performance with Fargate on ECS moving even faster than the EKS on EC2 option. When we move to scale into thousands of containers though, EC2 does take the lead from Fargate. It is up to you and to your company to decide if this performance improvement is worth the extra maintenance cost as compared to Fargate on ECS. Of course, there is still Fargate on EKS, there are still ECS on EC2, and those can still be used, especially in combined workloads. There is nothing stopping you from doing that, and it is a best practice. What about millions of containers? Well, we're not going to be covering that here, unfortunately. Those kind of workloads are very much application dependent, company dependent, and people move to using multiple clusters with likely custom solution. That is a more in-depth topic that is very specific to each company, so it's not something that we could be covering here and bringing any value. In closing, AWS is continuously improving. We've seen how much Fargate improved from spring to winter, and that came with absolutely no effort involved on the user side. Generally, for most workloads, Fargate on ECS is a great starting point, and you can easily migrate from Fargate on ECS to any other orchestrators when your requirements change and dictate that. That said, if you are running workloads that have more zealous requirements, like we discussed, GPU support, intense networking requirements, specific CPUs, Kubernetes and EKS are very much required and a very good option. My personal opinion is that Fargate is pretty much overtaking EC2 for general workloads. It is very easy to get started running containers at huge scale, and the effort on the company and the team is significantly smaller. You can then move your focus on making your applications more resilient, making your applications better, and focus on delivering value faster for your customers. You can focus on reinventing your company. Thank you so much for watching this, and don't forget to complete your survey if you want to see more community talks like this and if you want to see me back next year. Thank you.